John. All right. Hello, everyone. Before I start, again, a huge shout out to both John and Victoria, all the speakers, and also everyone who's here. I think it's really commendable how everyone is coming together despite the tough world that we are living in and how we are adapting and still learning great things as a community. So I'm super excited and super grateful for this opportunity today. My name is Divya Jain. I have been a mobile app developer and especially an Android enthusiast for many years now. I'm currently based out of San Francisco. Apart from writing code, I blog, I speak, mentor, and love to deep dive into the mobile habitat. I also love to chat, especially anything technical. So feel free to reach out to me anytime on Twitter, GitHub, email, anything. And so today I'll be doing a developer's deep dive into the world of recycler views, which is one of my favorite topics. So let's start. All right. All right. So it is obvious that majority of the apps that we use these days have some kind of scrolling functionality where the user is displayed a list of data represented in the form of related items. Now, whether it is social media, any OTT platform, even something as simple as your email app or contacts, it's usually some sort of collection of data shown on the screen, which means the app is essentially querying data and showing the list of results. So, therefore, a list view which creates these long scrollable lists of data becomes a very, very important part of any mobile ecosystem. Now, all of us in the Android world currently know that when it comes to displaying any kind of list, the obvious choice is using a recycler view. And a deep dive into the workings of a recycler view and why is it efficient is the whole conversation we are going to have today. But for history purposes, I believe it's necessary to look into the legacy Android list view, which is how I started writing code years ago. So here's a code for a simple list view that represents a list of books. Now, as you see here, I added a list view to the XML layout inside a constraint layout tag, as I would add any other view or view group. And then in code for the main activity, in the onCreate method, we would just do a find view by ID for the book list view, which we added in the XML, get the list of books from the data source, which can be coming from anywhere. It can be a database, it can be a networking operation, and then create and set a simple adapter for the book list view. Now, the adapter here is an array adapter, which needs a context, a layout file, which in this case is a simple list item that contains the UI for each row item of the list and the data to populate, which in this case becomes the book items list. Now, let's briefly look at what an adapter is. Now, an adapter is a bridge between the data source and the UI component that is displaying the data. Now, it loads the information that needs to be displayed from any data source, creates a view for each of the item, and places these views into an adapter view. Now, a list view is simply a subclass of an adapter view. So it can be populated by binding to an adapter, as shown in the example before. Now, the list view itself is sort of a dumb view, but what it does is when it needs to display something, it asks the adapter, and the adapter is the one that fetches the next item from the data source, decides how to UI view, and then passes this information into the list view to be displayed. So now let's look into a custom adapter, which basically extends a base adapter. Now, one would need to implement certain methods which are required to be overridden. And so you have the get count, which tells the list view how many items to display, or basically the size of the data source. Then you have the get item, which returns the item from the data source for any given position. Then you have the get item ID, which simply defines a unique ID for each row in the list. And here we are just using the position. And then there is the get view, which is one of the most important methods, which is where the adapter is creating a view from the data to be placed in the list. Now, this is the method where first, as you see here, we get to inflate a custom XML view of how each of the items should look like, which is what is defined here by the list book item layout. Then we get the references to each of the subviews inside the item view, which here is a title and an author text views. And finally, we are populating each of these elements with the right book data. Now, implementing a custom adapter like this allows you to customize a lot of options for your list view. You can inflate and style from any kind of view you like for the items. It also lets us style the rows in any shape or form and enables us to make them more informative, also allows user interaction, etc. But at the same time, there are big performance issues with using a list view like this. Whenever the user starts scrolling this list view, the adapter's get view method will create and inflate a new row view every time to be displayed on the screen. And every time this method is called, it will further do the find view by IDs multiple times to find the sub elements, which we all know is very harmful, leading to a seriously janky scrolling experience. And not to forget that we are working with an app which is already constrained by the limited resources in a mobile environment. So now, in order to reduce these drastic number of repeat calls to the find view by ID, every time a new row view is created or reused, we use a design pattern called a view holder. Now, what a view holder does is that it stores the references to the IDs of the elements inside a row view. So we find the elements once, but there is no need for repeat calls to find view by ID every time the get view method is called. And there is immediate access to the rows sub elements. So based on this, you're inflating the subviews only once through doing your usual find view by ID. And all the other times, the views are either created or reused. The expensive operation is skipped, and the view holder is used to get access, which it has stored in itself, and to get access to the elements and set the appropriate data. Now, another thing to note here is if we see the signature of the get view method, we see something called a convert view. Now, the description of this convert view states that this represents the old view to reuse if possible. Now, this convert view is what is used to determine if a new view is created every time the method is called. So another possible optimization here is to check if this convert view is non-null and of an appropriate type. And if it is not possible to convert this view to display the correct data, then this method can create a new view. Otherwise, it can just reuse the convert view here to prevent expensive operation of creating, and again, creating a new view every time. So now, after that brief overview of how a list view works and the ways in which we can optimize it, let's take a look at what a recycler view is. Now, recycler views are said to be much more powerful, flexible, and a big enhancement over a list view. So we'll all understand that how and why. Now, from the definition, a recycler view is a UI component that allows to create and render a list of items using the holder pattern in any linear, grid, or staggered manner. So the data is coming from the data set. Adapter is the one binding this data to the views and passes it to, sorry. And so adapter is the one that binds this data to the views and then passes it on to the layout manager to control the display of these views. But the interesting thing is recycler view allocates only a certain number of item views that fits within the viewport of the screen. And as the user scrolls, it reuses those item layouts to be bound to the new data. So here, as you see in the diagram, once the view scrolls out of sight, it goes through a recycling process. So a view is first displayed on the screen. Once it scrolls out, it becomes something called a scrap view, which is temporarily detached from the view holder and put into a scrap heap cache. Now, a scrap heap cache is nothing but a lightweight collection. Now, in the case the user decides to scroll the view back again onto the screen, these views from the scrap heap can be directly reused and passed back to the layout manager directly, since the data is just in a temporarily detached way, but it's still attached. But when a new item needs to be displayed, which is from a different data, the view scrolled off of the screen becomes a dirty view. Now, since it's a dirty view is nothing but a view that needs to be rebound by the adapter with new data before displaying it on the screen. So at this point, we have a recycle pool which consists of all these dirty views, which can be bound again and then passed on to the layout manager. So overall, it becomes a continuous cyclic recycle machine where as the views are scrolled off, they are recycled with new data and they come back onto the screen. So ultimately, what we are doing is we are skipping inflation and creation of layouts drastically, hence enhancing the performance. So from the implementation perspective, a recycler view itself is a view group that contains the view that corresponds to the data. Now, since it's a view itself, we can basically just add it into any layout the way we add any other UI element. Now, in the list view, we saw how the view holder pattern provided the necessary optimization. With a recycler view, each element is mandatorily defined by a view holder object. Now, one can extend the recycler view.viewHolder to define the view and bind data to it. And we still have the necessary adapter methods to implement where the creation of the view and the binding of the data happens, as we'll see in a code in just a minute. And then lastly, we have a layout manager that arranges these items in the list. So one can use any of the existing layout managers like linear, grid, or actually define a custom one itself. So overall, if we are looking to implement a recycler view, there are three major steps. A, plan the layout, which means determine what kind of a layout manager will display your data. Second, design how each element in the list would look like, which would be extending the view holder, which is a wrapper around the row view. And then third, define the adapter, which will associate the data to the view holder view. So we've already established that an adapter and a view holder are the two key classes that work together to display data in a recycler view. So now let's take a look at a simple adapter and view holder implementation. Now, as you see here in the code, when we define a recycler view adapter, there are three key methods that needs to be overridden, and they are the ones highlighted. So first, there is an on create view holder, which this is a method which is called whenever a new view holder is needed. Now, this method just creates and initializes the view holder along with its view and simply returns it. Now, at this stage, there is no data binding. Then we have the on bind view holder. Now, this is the method that is used to associate a view holder with the view holder's layout. With uh, this is the method which is used to associate a view holder with the data. So now, when we get the appropriate data based on the position and fill the view holder's layout with this data, so let's say our view layout contains a text view to display a book title or something. In the on bind view holder, we'll get the title of the respective book at the corresponding position and then set the text as needed. And then lastly, we have the get item count method, which returns the size of the overall data set that we've passed to the adapter. So now once we've defined the necessary code and the functionality in the adapter and have taken care of the view holders to create and bind data to our UI, in our main activity or fragment, we can add a recycler view similar to, again, how we add any other UI element. So the XML will have something like what is shown here, the recycler view tag with the necessary IDs and the necessary ID and the constraints. And in the code, we can get the data set, which is represented by the list book items here, initialize the adapter with this data set, and simply set the adapter of the recycler view for everything to work together. Now, one important thing to note here is the attribute layout manager. Now, this attribute is super important. If we don't set a layout manager to our recycler view, and of course, it can be set in the XML or programmatically, the recycler view will have no idea how to display the list. And so it will result in an empty view. So if you ever see an empty recycler view, and this has happened to me multiple times, you might wonder why there is nothing showing. In most cases, it is because we forget to set the layout manager. All right, so now that we know how recycler views work, let's reiterate how they are beneficial and provide much more enhancements over a list view. Now, firstly, recycler view requires, as we saw, requires a mandatory view holder pattern to create or recycle its views, which might mean more boilerplate code, but it provides and comes with a lot of optimizations. Now, with a list view, there was only a vertical layout possible, but recycler view supports multiple layout managers. And it is just as easy as just setting a layout manager attribute. There is linear layout manager, which supports both vertical and horizontal scrolling. There is staggered, which supports staggered list, something like Pinterest. And then there is grid layout manager, which is something like the gallery app or the Instagram grid display. Or again, as I said before, one can also define their own custom layout manager if need be. Now, with recycler views, there is also an out of the box item animator class, which makes animating the views very easy and intuitive. There are a bunch of good examples out there to play with. With recycler views, there is also an easy support for adding dividers or decorating items like borders, etc., through and again another class called item decorator. And of course, there is overall much more customization abilities and power provided to the developer through easy out of the box methods and APIs. For example, interacting with the individual items through a simple on click listener, etc. But of course, like the biggest advantage comes from recycling the views instead of creating new ones, and hence the performance is dramatically faster and optimized. Now, there are some further tips which help provide more optimizations to the way Recycler View functions. And so let's briefly take a look at these methods. So first we have set has fixed size, which takes a boolean. So now if we know that we don't want the items of the Recycler View to change their size based on the content, then we can set this method to true in the initialization of the recycler view. Now, with this method, the recycler view knows not to recalculate the item size every time a view is created or recycled, which further improves performance significantly. Another method which is helpful is set item view cache size. Now, this lets us set the number of off screen views to retain before adding them to the recycle view pool. Now, these are the views which have barely scrolled off the screen, and the recycler view will hold on to them. So, if the user decides to scroll them back to the view, then there is no need to re execute the on bind view holder method. Basically, there is no binding of data happening again. And then finally, we have the adapter method, which is helpful to set stable IDs, which are further helpful for animation and visual persistent purposes. All right, so till now, we've been discussing about recycler views where every row item has the same UI, which basically means that recycler view with a single view type. But with the kind of complex UIs and the advanced data that we work with these days, there are many a times a need to display various kinds of data in the same list for different kinds of elements. So let's take a brief look uh, as to what should be the strategy to implement something like that. Now let's go back to our book examples. Let's say we want to divide the display of the books based on genres. We might want to display a section header for each genre and follow it by the books belonging to that particular list. Now, the two important things to remember here are that A, the data items will have two different subclasses. So as you see here, we have one sealed class called the data item, which further has subclasses, which is one for the genre name and the other for the book item. And they respectively take the right data models based on what kind of item they are. Now, in the create view holder, based on the view type, one would create different view holders for different data items. Now, in the individual view holders, you can inflate different XMLs for what UI would you want to display based on the type of the view. So, for example, for the genre one, it might just contain a single text view for displaying the genre name and might have a different color. But for the book related row, it might be more informative about the carrying the book title, the author, and more information, for example, like the book rating or any image, etc. So the whole idea is that individual view holders will take care of the individual UIs related to different kinds of items. Now, a method which is super important to override in this scenario would be the get item view type method, as you see here. Now, this method is what helps us determine the type of the data that is present in the data set, and then which will further help determine to bind this data to the correct view type. So as you see here in the bind on bind view holder method, it using this method to get the view type, it gives you the type of data, whether it is a book or a genre, and then we would use the corresponding view holder to use their bind method to bind data correctly to the right kind of view. So this was just a brief overview, but this kind of implementation helps us scale recycler view to incorporate multiple kinds of views. Now, there is another class available with recycler view adapters now, which is called the concat adapter. Now, this lets you combine multiple adapters sequentially and display them in a single recycler view. Now, one might ask, when will this be helpful? Now, there might be scenarios where one might have multiple data sources, and either one option is either you combine all the data sources into a single adapter, but with this concat adapter, you can actually create multiple adapters themselves. So you're basically encapsulating them and keeping them separate, which will be helpful in keeping them focused. They can be reused anywhere, and it also makes them individually testable and scalable. So one use case might be the header, a list, and a footer. So we can have separate logic for header, footer, list in 3 individual adapters, and then use concat adapter to display them in a particular order. Now, this way, there is a separation of concerns and clean code without any mixing of business logic. So concat adapter is again a very powerful tool. It comes with its own set of customizations, where if multiple adapters are using the same view holder display, then it also allows you to reuse the instances of these view holders. Again, if you want to check out further details about concat adapter, there is an amazing article on Medium written by Florina, and I have added a link to it at the bottom. So I highly, highly recommend you checking it out. So another question that gets asked often is nested recycler views and how are they implemented and used. Now, one of the most obvious examples of this kind of view is the Google Play Store. Here, where you not only see the main screen itself is a list that can be scrolled vertically, but individually, these different items further have lists inside them, which can be scrolled horizontally. Now, most of the streaming apps also, like Netflix, Spotify, Prime, these days are using this kind of display. And I feel it's important to briefly go over the strategy to implement such UI. Now, for a detailed example, feel free to browse over to my GitHub. Now, so this is the situation where we use nested recycler views. So one recycler view is a parent to another recycler view. So the vertically scrolling list becomes the parent recycler view, and the carousels, which scrolls horizontally, becomes the children nested recycler views. So as we see, there are several components involved here. There is the main XML layout for the activity or the fragment, which contains the parent recycler view. Now, the parent recycler view will have a layout for each of its row item, which is the parent recycler view item here, the second thing shown. That will contain the text for the category name, let's say, and the child recycler view, which is horizontal in this case. And then we have the child recycler view item, which will have its own UI implementation of what is displayed in each of the items. It might be a card view, it might just be a simple image, might have a custom UI implementation that's dependent on the UI. So in this scenario, we'll also have 2 different data model classes. One for the individual items like a movie, or in the Play Store case, each app that is displayed. And the second one would be for each of the categories, which would have the category name and the list of apps that belong to that particular category. Now, not only that, we'll also have 2 different adapters here. One would be the child recycler view adapter, which will hold the information that belongs to the child recycler views and bind this data to the child view holder. But the second one is the parent recycler view adapter, which will not only hold the information that belongs to the parent recycler view, but in the bind method of the view holder, is where we'll actually set the data for the child recycler view also based on the category. Because each category will consist of its own data. Whenever each category is bound to its respective child view holder, this will be the place where we set the data for each child recycler view. It's a simple step by step implementation, might sound confusing, but there are a bunch of amazing examples on GitHub for the same. Now, before I end, there is no conversation in the Android world these days that can go without mentioning Jetpack Compose. And so the natural question is, how does one implement recycler view in Compose world? So as you see here, this is from one of the Compose dev challenges, which we did when Compose was announced. And it shows a list of puppies up for adoption in a grid layout and is, of course, scrollable. So let's see how we would go about implementing it in Compose. Now, a couple of things to note here is, let's say you are working with an existing app which already has this functionality implemented and following an architecture pattern like MVVM or MVI, or basically any of the unidirectional data flow pattern. Then the beauty of having such an implementation is that Compose works really well with such patterns. And it becomes easier to switch out the UI from the imperative XML way to the declarative UI, which is what Compose is all about. So let's say in this case, we have a data class for the dog and a dog repository, which provides the data used to display here. Let's also say we have a view model which gets the data from the repository and exposes this data to the view in any sort of observable manner. The good thing is we don't need to change anything about that implementation, since the business logic is all separated out and it has nothing to do with the UI, or actually doesn't even have a knowledge of the view that's consuming or observing this data. So let's go about displaying a list in Jetpack Compose. Now, Compose provides a composable called lazy column, which is equivalent to a recycler view. It's it's pretty easy and amazingly much less code, as you can see here, which lets you not only describe attributes to add padding or any other styling to the recycler view itself, but also provides an items function, which is where you pass data which needs to be displayed in the list. And then there is another composable, which is the item content, which is what populates each items of the list. So this way of writing enables you to extract each composable function to its own, which makes the code much cleaner and easy to follow. Now, one thing, if you notice here in the screenshot, we are using a grid display instead of a regular list. So one thing to note here is, instead of lazy column, we need to use lazy vertical grid, which is another composable provided to support grid-like display. For the complete code, I have the link to my GitHub in the slides, so feel free to check it out. All right. So to summarize everything we talked about today, recycler views are great flexible views that help display a large set of data on a limited screen. They are much more fast and provide optimized performance for the user to be able to scroll through the list smoothly. They come with a highly versatile API, which allows developers to provide a lot of customizations and power over how to render different kinds of data. There is a lot of recycling and under the hood support for dynamic rendering of the data, which means if and when the data changes and the recycler view is notified, there are efficient updates to accommodate these changes. Because of these optimizations, it automatically means reduction in memory or power consumption and less load on the resources, especially in comparison to the list view. And of course, there is enhanced responsiveness, which leads to a fruitful and beautiful user experience. So more power to recycler views. And with that, it's the end of my talk. I am sticking around, so happy to answer any questions now or later in Slack.
Yeah, we've got a few minutes, so we can definitely take some questions here. So if anybody has one, feel free to drop it into Slack. Lauren asked a question: is the scrap heap the same as the recycler view heap that can become dirty views?
So there is, so when you go deep, dive into the underhood of how recycler views work, the scrap heap might not be exactly same as the recycler pool heap or recycler pool, which is what is called. So with the scrap heap, initially the data is still temporarily attached to that view. So in case, the way I understand it, in case the user want to get the scroll the view back into the viewport, there will not be any rebinding of data. But once you are picking up dirty views out of a recycler pool, that is where the view is dirty, which means there needs to be a rebinding of data that needs to happen before it can be scrolled onto the screen. I hope that answered the question. Yeah.
We got one more. What do you think about recycle view abstractions like epoxy made by Airbnb? If you've ever heard about it.
I have heard about it, but I unfortunately don't have much experience around it. So I would, instead of saying anything wrong, I would rather do a research and get back to you on that.